When a function stops increasing and starts decreasing, something important happens. In this lesson, we'll learn how to identify stationary points and classify them as maximum, minimum, or neither. What is a stationary point? A stationary point occurs where the first derivative equals 0, that is f prime of x is equal to 0. At this point, the graph has a horizontal tangent. It could be a local maximum, it could be a local minimum, or it could be a point of inflection. Here are the steps to find stationary points. First, find the first derivative. Compute f prime of x using differentiation rules. And if derivatives feel overwhelming, I created a free fast-track derivatives cheat sheet that walks you through every derivative rule. You can download it using the link below. Then you'll need to set the derivative to 0. You'll solve the equation f prime of x equals 0 to find critical points. And then you'll need to classify the points. Use the sign test, preferably, or the second test to determine the nature of the stationary point. In this lesson, we'll focus on the sign test, and in the next lesson, we'll go over the second derivative test. Now, let's compare the three types. First, a local minimum occurs when the derivative changes from negative to positive. That is, the function goes from decreasing to increasing. The local maximum occurs where the derivative changes from positive to negative. That is, the function increases and then decreases. And a point of inflection occurs when the derivative doesn't change sign. The function continues in the same direction on both sides. So let's see how this applies through examples. In our first example, given the function f of x equals x squared minus 4x plus 1, we want to identify if there's a maximum minimum of point of inflection. So the first thing we'll need to do is find the derivative. So the derivative of f of x is f prime of x, which is equal to 2x, that is the derivative of x squared with respect to x, minus 4, that is the derivative of negative 4x with respect to x, and the derivative of 1 with respect to x is simply 0. So we have f prime of x equals to x minus 4. In step number 2, we'll let that derivative be equal to 0 and solve for x. So if we add 4 on both sides and divide by 2, x is equal to 2. Then we'll need to use the sign test. So we can choose any point on the left side of 2 and any point on the right side of 2 to see the sign of the derivative. So let's say that on the left of 2, we pick the point x equals 0. And if we substitute x equals 0 into a derivative, 2 times 0 minus 4 is negative 4. That means that the derivative is negative. Therefore, the function is decreasing on that interval. We'll do the same thing on the right of 2. Let's say we pick x equals 3. If we substitute x equals 3 into our derivative function, 2 times 3 is 6. 6 minus 4 is 2. Therefore, the derivative is positive, which means that the function is increasing on that interval. So if the function goes from decreasing to increasing, that means that we have a local minimum at that point at x equals 2. And we can clearly see it on the graph. You have a local minimum at x equals 2. In this next example, we want to find the local minimum, maximum, or neither of the function f of x equals negative x squared plus 2x plus 3. So first, find the derivative. F prime of x will be equal to negative 2x plus 2. Set this to be equal to 0. And if we subtract 2 on both sides rather and divide by negative 2, x is equal to 1. That is the solution when we set the derivative to be equal to 0. So now we can test two intervals, from negative infinity to 1 and from 1 to positive infinity. If you pick any point on the first interval from negative infinity to 1, you'll find that the derivative is positive, meaning the function is increasing on that interval. And if you pick any point from 1 to positive infinity, on that interval, you'll see that the derivative is negative, meaning the function is decreasing. So since my function goes from increasing to decreasing, there is a local maximum at x equals 1. And looking at the graph here, we can see that the function is increasing from negative infinity to 1 and then decreasing, which creates a local maximum at x equals 1. Now, given the function f of x equals x cubed, if we find the derivative, f prime of x is 3x squared. Setting 3x squared to be equal to 0 and solving for x, you'll find that x is equal to 0. So using the sign test, on the left of 0, okay, you could pick any point. Let's say you pick x equals -1. You'll find that the derivative is positive, meaning the function is increasing. And the derivative is also positive on the right of 0. So let's say you pick x equals 1. Once again, the derivative will be positive, and therefore that means that the function is increasing. So the function increases on both sides, as you can see here on the graph. But it is neither a maximum or a minimum. This is what we call a stationary point of inflection. Once again, if the sign of the derivative doesn't change, that means that we have a stationary point of inflection. So here's your challenge for today. Find and classify the stationary points for the function f of x equals x cubed minus 3x. First, find the derivative. Then solve f prime of x equals 0 in order to find the critical points. And then use the sign test in order to attest whether it's a maximum, minimum, or neither. And if stationary points finally make sense, you're ready to tackle more advanced calculus concepts. Remember, find the derivative, set it to 0, and use the sign test to classify. And if you still need more help with derivatives, remember that I created a free fast-track derivatives cheat sheet that walks you through every derivative rule. You can download it in the link below. Thanks for watching, guys. Please like and subscribe. And remember, math success starts when you stay on the fast track.